Okay, so we're going to try something called special right triangles, which really is something that comes straight out of Pythagorean's theorem, sort of. I mean, how we calculate it is, but the point behind it is that these are two kind of critical triangles we deal with, and they will help us in trigonometry and beyond. So so we have the 45, 45, 90, which is just an isosceles triangle because two angles are the same. So then two sides are congruent. And then we have a 30, 60, 90 triangle, but it's built off of an equilateral triangle. So we're just going to start with the 45, 45, 90. I don't know how long the video will be, so if it's too long, we'll just stop on this one, and I'll make another video with 30, 60, 90. But it's an isosceles triangle, which means that the base angles are 45 degrees, right? And that's how I know I'm talking about a 45, 45, 90. Three angles, all three add up to 180. One's 45, the other's 45, one's 90. So I want to know what is the length of each of the sides. So we are going to generalize a rule, and we can do that here and generalize a rule to help us solve all of these problems. Now, I think we could use Pythagorean's theorem, and we're going to do that because we know enough information, and Pythagorean's theorem will help us generalize the rule. And so we know that this side is the hypotenuse, and we know that we have a squared plus b squared equals c squared. So we can kind of look at it here is that a and b are the legs, because another way to write this is that we have the leg squared plus the leg squared will equal the hypotenuse squared, and this is kind of Pythagorean's theorem at a very basic level in terms of what it is. So I know that the leg is x, so squared plus x squared will give me, and I'll just use the hypotenuse squared, so why not just call it h squared for hypotenuse, and we'll simplify it. And so I have 2x squared equals h squared. So now if I take the square root of both sides, I know the length of the hypotenuse, right? And I'm going to break this up just so we can see it. We have these two things, and this is the square root of h squared. And you should remember the square root of anything squared is itself, and that's why we do this, so that we can see that. And so we're left with the square root of x squared is x, the square root of h squared is h. And so the hypotenuse, we can generalize that the hypotenuse equals the square root of 2, right? Is equal to the leg times the square root of 2, right? That's what it equals. This right here, we have the hypotenuse, we have x as a leg, right? And we know x is either leg, so the leg times the square root of 2 is the hypotenuse. And so let's kind of generalize that rule, right? The leg times the square root of 2 is the hypotenuse. That's the general important aspect of it. So we can now look at this equation, but let's look at it in terms of a leg. So the leg, here is the rule. We'll put it over here. We'll say the leg times the square root of 2 equals the hypotenuse, right? All right, well, let's go and check this out. Let's just see if that makes sense. So let's just take over on this triangle, example 1. Let's use our formula. H equals the leg times the square root of 2. Oh, the leg is 10. Oh, look at that. We are already finished. 10 times the square root of 2 is this length right here. So 10 times the square root of 2. Okay, well, can we prove it, though, just so we don't get stuck just using this general rule? Why does it work? Because I know that a squared plus b squared will equal c squared in the example, right? So c would be this side, and this would be a, and this would be b, right? The leg, the hypotenuse. So if this is a tick mark, then this side is also 10. So I'd have 100 plus 100 equals c squared, and I'm just kind of showing you the logic of why this is working. I'm not going to do this every time, but if I add these two together, I have 200, and that will equal c, right? Because I take the square root of both sides. And then I can factor it to 100 times 2, which is c, which is 10 square roots of 2, which is in fact what we had just by plugging in 10. So let's look at this one. I am not given either of the isosceles, but can we still use h is equal to the leg times the square root of 2. Well, I can. I am given the hypotenuse. I know it's the hypotenuse because it's directly opposite the 90 degree. Notice I did that on purpose. I rotated all of these just so you would recognize that the hypotenuse is not always cleanly presented, and you do kind of have to be able to observe it. But if I plug in 8 for the hypotenuse, I get the leg times the square root of 2. And so now we can just solve for the leg, right? We divide this on this side. Now we have 8 over the square root of 2. Now, from your radical experience, you should recognize that we don't want to leave an irrational number, and this is irrational in the denominator. So I want to multiply 8 over the square root of 2 by a value of 1. So let's just go off to the side here for a second. Let's say if I multiplied 8 times 1, I still get 8. It doesn't change its value. So if I could multiply the square root of 2 by a value, just to keep this whole thing the same, right? Well, if I multiply the 8 over the square root of 2 times 1, right, because anything divided by itself is 1, then I'm keeping it the same value. And so I just switch the order, and that's here, and then it's over the square root of 4, because 2 times 2 is this. So I get 8 square roots of 2 over 2, which is 4 square roots of 2. And so this side right here is 4 square roots of 2, which means that this side is 4 and this side is 4. And if we look at it, if I plug in, I'm sorry, wait, I apologize, I made a mistake. This side is not 4 square roots of 2. I'm jumping the gun because I'm looking at different questions, but this side is 4 square roots of 2. Why is that the case? And this side is 4 square roots of 2. Why is that the case? Because this is the hypotenuse, right? And if this is the hypotenuse, the leg has to be less than the hypotenuse, right? So 10 times the square root of 2 is greater than 10. 4 times the square root of 2 is less than 8 because the square root of 2 is 1.41 something, and so 4 times 1.41 is less than 8. So we can kind of see that these would be the way we do it, and then we could go over here, right? This is the leg, and so we can go back to the formula, and we can plug in the leg, 5 square roots of 8 times the square root of 2. So what is the hypotenuse on this one? Well, 8 times 2, because they're both underneath the square root symbol, I can multiply them, and 8 times 2 is 16, and the square root of 16 is 4, so I get 20. So the hypotenuse on this one is 20 when the segment length is 5 square roots of 8. So this is just how to use it. It can get a little more tricky than this. So, but in general, if you can use the formula for any situation. You just have to make sure you rationalize the denominator. And this works. This is the only thing you really need to figure out a special right triangle of a 45, 45, 90. Now, you can also use Pythagorean theorem because it will also cleanly work every single time.